Next, we're gonna work on exercise 24, which is from the Mathematics of GIS by Wolfgang Kens. So this exercise 24 is given the geographic coordinates of Vienna Airport as phi 48.12, lambda is 16.757, and the radius of the Earth as r, and we compute the Cartesian coordinates of the airport when the origin of the Cartesian coordinate system is located at the center of the Earth, and the axis direction are illustrated in figure 17. So we can go to figure 17 here. So based on this figure, we can see that we have phi, we have lambda, and we have r, which is mp, the distance from m to p here. What we need to do is we need to calculate x, y, z of p, or 3D Cartesian coordinates of p from geographic coordinate phi, lambda, and radius of the Earth. So in order to do that, we're gonna implement it in Python. So actually I already did it in Python here. So in order to do that, we're gonna use the formula from figure 16 in this document. So if we see the figure, we can see that in this figure, lambda is equivalent to phi, and phi is equivalent to theta. Actually 90 minus theta. So let's jump into Python and start doing this exercise. Okay, so in order to make it easier for us to follow, I have my reference here as I did it already. I'm going to make a new cell, and then firstly I need to import numpy as np, run it. After that, so I'm going to decide to just copy and cut it here, numpy as np. So what I'm going to do is firstly I'm going to convert. So I'm going to have the given thing here, which is try to ignore this. So the given thing here, which is phi is 48.12 degree, and we need to convert phi from degree into radians using radian function in Numpy. And it's also because the given is phi, but the notation to this formula is actually theta. So what we need to do is we need to find theta. It's actually a bit confusing. We will say that theta is in degree, is actually 90 minus phi in degree. We run that, and we're going to have theta is 41.88. After that, we convert theta into radians from degree using Numpy radian function. So in order to do that, we just make theta with radian, and then we put theta inside here, and finally we print out theta in radian. So now we have theta in radian. What else is given? We are given lambda, which is equivalent to phi in this figure. So we're gonna get lambda is equal to lambda degree. But we can say that which is phi degree, which is 16.57. So we done up to here already. So now we can convert phi to radian, which is numpy.radian, then put in phi degree here to convert from degree to radians. Then if we print this out, we can have phi angle in radian. Then we also are given r as well. After that, we just follow this formula. After we have r, we have theta, we have phi. Then we just use this formula to calculate x, y, and z 3D Cartesian coordinates of p. So now it's very easy. So now x, when we say calculate 3D Cartesian coordinates of p of the given point. So now x is actually r multiplied by sine of phi multiplied by cosine of sine of theta and multiply cosine of phi. So we got here theta, which actually theta in radian, and phi here is actually phi in radian. Okay, but if we run this, you're gonna get an error because Python doesn't understand sine and cosine this way. So we need to call numpy.sine and also numpy.cosine. Then we can have x value, which is 4000. This is in kilometer. So actually we need to convert this into meter as well. So it should be 0, 0, 0 here. So now we can have the coordinate of this point, which is 4,000, 400,000. Actually, which is 4 million, isn't it? I know, yeah, it's 4 million. Next, we're gonna do for y. So the same y is actually y and sine of. So if we look at this formula, sine of theta, then multiply by cosine of phi. Yeah, and similar, we know that theta should be radian and phi should be radian, and also sine should be from numpy or from math is okay. And yeah, if I put in import math here, I can also use math.cosine. It's the same function. Then I have y. So we got that. This is y. Actually, this is actually sine here. So I got x and y now. To group like that, we have x and y. Next, we also need to calculate z. So z is actually using this formula, very short, that z is equal to r cosine of theta. So that is r cosine of theta. And of course, theta need to be radian and cosine need to be from numpy or math. Then now we get x and y and z. So that's it. If we have the input is this angle, and radius of the Earth, we can calculate the Cartesian coordinates of a point on the Earth. So this is actually not the real coordinate system that we use in the real world in GIS and surveying, but it's a good step to as a fundamental concept to understand how to convert from geographic coordinate to 3D Cartesian coordinate. And from there we can go a step further to understand how to convert from geodetic coordinate to projected UTM or projected coordinate, such as the UTM projected coordinates. So again, I use the reference of the reference for this video is this book online. You can access it freely from this homepage. So, and also please keep your comments and suggestions down below for a better way to calculate this, and we will come back with other video relating to this series about math in GIS.